This is Dr.D Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. The today topic is free body diagram, types of forces acting on a body. Types of forces. In engineering field, the various forces are acting on a body, but broadly they are classified into two types. They are applied forces and second one is non-applied forces. The applied forces are the forces which are applied externally on a body. Depending on type of their contact of the body, these applied forces are classified into point loads and distributed loads. The point load is the force which has got contact with the body at one point, or in other words, it is acting on a point. The area of the contact between the body and the force is infinitesimally small. Hence, this force is called point force. Distributed force. These are the forces distributed over the body, maybe in the form of line or surface or the volume, and these corresponding forces are treated as a linear force, surface force, as well as the body forces. The linear force is the force which is acting along the line of a body. The surface force, a force acting on the surface of the body, is known as a surface force. The best example is a hydrostatic pressure acting on a dam. And third one is the body force. A body force is the force exerted from each and every particle of the mass of the body. The best example for the body force is the weight of the body. Non-applied forces. These forces are not applied on the body. They are the self-weight as well as the reactions. The self-weight, every body subjected to gravitational acceleration and hence got a self-weight which is equal to W into, which is equal to M into G. Reactions. These are self-adjusting forces developed by the other bodies which come in contact with the other body under consideration. According to Newton's third law of motions, the reactions are equal to the in magnitude but in opposite directions. Here the best example I am taking now. This is the weight of the body. There, it is kept over the table. The weight is acting in downward directions, but the body is in equilibrium positions due to the reaction force offered by the table on it. Or we can represent it as now, that is the weight is acting downward directions. The reaction force offered by the surface of the table is acting in upward directions. Both are in equal in magnitude and acting in opposite directions. The force exerted by the table on the body is treated as a reactions. The force exerted by the body on the surface of the table is treated as a action. The action and the reactions both are equal in magnitude and acting in opposite directions. Free body diagram. The free body diagram is most important for analyzing the forces which are acting in a body and what it is the effect. This is most important, particularly the students who are interested to settle in structural engineering. The free body diagram, first the body is drawn, then represent the applied forces, self weight, and the reactions at the points of contact with the other bodies are drawn. Such a diagram of the body in which the body is under consideration is free from all the contact surfaces and show all the forces acting on it, including reactions at the contact surfaces, is called free body diagram. The free body diagram, it is showing only the forces which are acting on it, including the reactions. Here the example I am taking. The first body, it is representing, it is having support, it is roller, it is in equilibrium position when the two forces are acting on it. When it is self-weight is acting downward directions, but it is balanced by the reactions offered by the support on the body. Hence, the second figure, it is representing free body diagram in which the weight is acting downward directions and it is balanced by the reaction force offered by the roller on the body. Both are equal in magnitude and acting in opposite directions, hence the system is in equilibrium position. Similarly, the second one is it's a pin joint. It is also called hinged. This joint is preventing to fall the body in downward directions as well as along the axial directions. When a force is acting on it, as in this is a force acting on it, the body is it will not move along the x directions as well as the y directions. Hence, the reactions developed at the pin joint, it is having two components. One is along the x direction fx and the y directions fy. These two are unknown quantities. Depending on condition of the body, we can determine the forces fx and fy. The resultant is, it may be in the form of this r. At the same time, again, it is represented with the directions theta. Again, it is having two components r and theta now to represent the resultant force. But for analysis purpose, generally the resultant force is resolved into two components fx and fy. Hence, the reactions, it is easy to represent this reaction force as well as the directions by fx and fy components which are acting along the x direction as well as the y directions. The third one is the fixed support. Even though the force is acting on it, it will not deflected at a fixed end. Hence, in order to keep the body in equilibrium position at a fixed end, it is preventing its motions in downward directions as well as the x directions. Hence, two types of reactions that are developed, fx and fy. At the same time, the moment created by the force P also minimized. Hence, that is the reaction force, that is the moment of couple, which is in anti-clockwise directions, that is developed. at fixed support. Hence, from these conclusions, when the body is having a support of knife edge, roller support, it is having only vertical reactions. In second case, when the body is having injured support, two types of reactions that are developed. One is along the x direction, one more along the y direction. And third, fixed support, three types of reactions that are developed. That is two types of forces, one is along the x direction, one more is along the y direction. So the third one is the moments created by the forces also developed into fixed ends. Hence, at a fixed end, it is having three types of Fx, Fy as well as the moment created by the force which is acting on a body. So, when we analyze the forces, the supports like roller, pin as well as the fixed supports are there. These supports are replaced by the reactions which are offered by the support on the body. Then the body is treated as a free body diagram. Here some more examples I am taking. The first one is the roller resting on a surface. Here it is preventing fall in downward directions. Hence, while drawing free body diagram, here R is the reactions offered by the surface and W is acting in downward directions. Here the W is equal to R. The weight is treated as which is force exerting on a body on the surface of the table. This force is treated as the action force. R is treated as the reaction force which is keeping the body in equilibrium positions. The second figure representing a ball is hanged vertically downward directions. If the surface is not there, the vertical surface, the body tends to move in clockwise directions. Hence, while drawing the free body diagram, the rope is there, which is preventing its motions in downward directions. The reactions within the rope is always away from the object and along the direction of the rope. Hence, the tension in the rope, it is represented by T. Its direction is along the direction of the rope. Second is the weight is acting vertically downward directions. The vertical surface is preventing its motions toward the left side. Hence, this R is treated as a reaction offered by the vertical surface. This diagram is treated as a free body diagram because we remove the supports like cord, vertical surfaces and represented what are the forces are acting on a body. For analyzing the forces as well as their effect, it is known as the free body diagram. The third figure, it is representing a ladder. It is kept to the vertical wall as shown in figure. Assume the vertical as well as the ground surfaces are smooth. That means there is no friction force. When we are removing the walls, horizontal and vertical walls, the reaction offered by the surfaces are kept in a figure number should be. Let A is in A position now. At A position, the P force is acting to prevent its motions toward the left side. So P is there, already it is acting externally. The weight is 600 newtons as well as the weight of the ladder, they are acting downward directions. Hence, the reactions at A, that is the RA is acting vertically upward directions. Similarly, at vertical surfaces here, it is also preventing the ladder to move toward the right side. Hence, the reaction is acting toward the left side. 600 newtons, that is external forces acting on it. This is called the applied force. And weight is also acting at its center of gravity. These two are in downward directions. That means the ladder is now showing all the forces which are acting on it, as well as the reactions offered by the vertical as well as the horizontal surfaces. Hence, it is called free body diagram. And fully, I am taking the fourth figure. Here, we can draw the free body diagram for the body 400 newtons as well as the 600 newtons. When you are taking 600 newtons, the tension in the rope is acting in upward directions. Weight is acting downward directions. On drawing again free body diagram for the second body 400 newtons. The 400 newton is there. The load is acting 400 newtons in downward directions. And tension in the rope is acting upward directions. Under condition of these two forces, the body is in equilibrium position. These are the just giving explanations regarding the direction of forces which are acting on a body when it is having roller support, pin support, fixed support, as well as the cable support. These are some more examples I am taking now. In the second case, the roller is there. Now it is pulling 5 kilonewtons force toward the right side. It is having weight 10 kilonewtons. But the body is preventing its motions by using the rope which is attached to it now. The free body diagram for this figure is, you have to draw the body as it is. Here for drawing free body diagram for the second figure, the weight is acting vertically downward directions of 10 kilonewtons. 7 kilonewtons force is also acting at its center. 5 kilonewtons acting in horizontal. But the body is in horizontal positions. The body is in the equilibrium position. Due to the cable which is attached at a point A, which is making an angle of 30 degrees. The free body diagram for this object is, draw the circle, the body, what its shape it is having, and represent the external forces which are acting on it, such as 5 kilonewtons, 7 kilonewtons, and 10 kilonewtons vertically downward directions. And the tension in the rope is always along its axis and away from it now. So by using equilibrium conditions, we can determine the magnitude as well as the direction of the force which is acting in a rope. Now, one more figure is there, the circle is there. It is pulled against the support of the step which is shown in figure. It is having contact at A position now. P force is acting toward the left side. The free body diagram is represented as circle only and represent what are the forces that are acting on it. That is the 2000 newtons acting downward directions. Its own weight is there. And the P force is acting the rope toward the left side. The reactions at A is represented the A, and we can determine its values again by taking condition of equilibrium. And last figure, it is representing a body sliding along an inclined plane. Here, in this case, assume the surface of the inclined plane is rough, it is having friction force. The body tends to slide, assume downward directions. A P force is applied on it in horizontal. The weight is acting vertically downward directions. And normal reactions, this is nothing but normal reactions offered by the surface. Since the P force is acting to push the object up the plane, hence friction force is acting in downward directions. In this type of problems, the forces are always resolved along the plane as well as the perpendicular plane, and apply equilibrium conditions. Sigma fx is equal to 0 and sigma y is equal to 0, and determine the unknown quantities which are acting on a body. Here, one more example. Electric fixture is there. It is hanged by using two cords AC as well as the BC. They are intersecting at a point C. This diagram which is showing the description of the body is known as space diagram. The figure second one is showing free body diagram for the electric light fixture. The weight is acting 15 newtons downward directions. The tension in the rope AC is represented here TAC. It is acting along the line AC. The tension in the rope BC is represented as TBC. It is acting along the line BC as shown figure. Now, applying equilibrium conditions, we can determine the tensions within the ropes. So, for solving engineering problems, for aeronautical as well as the mechanical and civil engineering students, you need to know the magnitude as well as the direction of unknown forces. First, represent the space diagram. That is actually just what is this forces that are acting on it, what are the type of forces are acting. Later, draw the same figure and represent the reactions offered by the supports on it, and resolve the forces along the x direction and the y directions, and determine the unknown forces which are acting on it. So, the free body diagram is the most important for the students to solve the forces which are acting on it. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.